Okay, in the previous video I mentioned that rational functions always have the same horizontal asymptote, left and right horizontal asymptote, and there's actually a very simple set of rules for figuring out what horizontal asymptotes are for rational functions. So rule 1 says that if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will always be y equals 0. So that's like this first case. If you look at this function, you have 2x over 3x squared plus 1. There the degree of the numerator is 1 and the degree of the denominator is 2 if I take the largest two terms. And as x gets really, really large, okay, as x goes to infinity, the leading terms of the 2x and the 3x squared plus 1 take over, right? That plus 1 isn't really going to contribute much when you put it next to x squared. So this limit as x goes to infinity is really the same as this limit, which is 2x over 3x squared. The leading terms take over. And if you simplify a little bit, if you cancel the x over x squared, you get 2 over 3x, and you're looking at the limit as x goes to infinity of 2 over 3x. That's going to be 2 over some really, really huge number, right? So the limit here is going to 0. And so that's what we find, is that y equals 0 is the horizontal asymptote for any rational function where the degree of the numerator is bigger than the degree of the denominator. So that's case 1. Case 2 is if the numerator and the denominator have the same degree, like in this example right here. If you want to take the limit as x goes to infinity of 2x squared over 3x squared plus 1, then the leading terms are going to take over again. So that's going to be equal to the limit as x goes to infinity of 2x squared over 3x squared, or just 2/3. Okay, so the x squareds will cancel. So you get the limit as x goes to infinity of 2/3, which is just 2/3. Okay, so y equals 2/3 is our horizontal asymptote in this case, because the degree of the numerator equals the degree of the denominator. And then the final case is case 3, and that's if the degree of the numerator is bigger or greater than the degree of the denominator. And in that case, there will be no horizontal asymptote. So in case 3, what happens is that if you take the limit as x goes to infinity of 2x cubed over 3x squared plus 1, that'll be the same as the limit as x goes to infinity of 2x cubed over 3x squared, which even after you cancel the x squareds, you end up with 2x over 3, but as that goes to infinity, you get infinity, right? If you plug in as x goes to infinity, the x will go to infinity. And so here there is no horizontal asymptote. In fact, the function is looking like the line y equals 2/3 x as x goes to infinity or negative infinity.